Number 5, we've got a quadratic equation here, and we want to graph it. The reason we're graphing this is so we can look at its characteristics. We're going to observe it and say, these are some things we know about this equation. These are some points that might be interesting to us. And there are ways to graph this by hand. Okay, you could use this equation and you could find some key points from it that we will talk about some next week. But for right now, you can go to your calculator. This is a pretty good plan. If you have this at your disposal, oh, I should not have deleted that. It was already there. You may have this at your disposal, and if you do, it's a very powerful tool. So let's learn how to use it. You hit y equals, and then you type in the function. Some things that might happen that won't allow you to graph it, sometimes one of these plots will get turned on. You see how that thing's highlighted? When I hit graph, it gets mad at me. Okay, so one thing you might have to do, go up there, hit the up arrow, and then hit enter, and turn that thing off. Sometimes you might have typed the equation wrong and it won't do it. Other times, let's see, maybe other times maybe your graph is zoomed in too much, so if you hit zoom in 6, it will take you to a standard window. Okay, and once you do that, hit second and graph, and it will take you to a table of values. And what you're going to look for is a place where there is some symmetry going on here. Okay, so look, -6, 10, -5, 4, -4, -4, 0, -3, 2, -2, 2. Haven't seen that one before. And we've got points that we can now put on our graph. So -6, 10, -10 won't fit, -5, no, -4, 0 will fit. It's right there. -3, 2 was another point, -2, 2 was another point, and -1, 4. Oh dear. Oh, -1, 0. Yeah, I got it. Okay. And 0, -4, which is down here. Okay. So what's wrong with this? Well, nothing. We're missing a point. It's right here. Okay. But we will find that one in just a minute. Okay. Now let's find it right now. Okay. We have not been able to find the vertex. So normally, if I were just to do a regular old quadratic function, y equals, I'll do -x squared. And look at these red values. You see one single number by itself. That's the vertex. And then you see this evenness on both sides, this symmetry. But one number is by itself, and that number is the vertex. Here we don't have a number that's by itself. The vertex is in between those 2 points, -2 and -3. But, like a lot of things, our calculator can help us find that point. So if we want to find that point, you're going to do what you did on to find zeros. Hit second and trace, but instead of going to 2, we want to find either a minimum or a maximum. If you look at that point, what is it going to be? The function goes up to that point and then comes back down. That is a maximum value. So you go down to maximum and you hit enter. Again, your cursor will pop up on the screen, or you might have to move it a little bit so you can see it. And it says left bound again. Okay, so left bound. We want to find basically this point where my cursor is right now. So you're going to do this. You're going to move to the left of that using your cursor. You don't have to go way to the left, just a little bit to the left, and hit enter. And now your calculator is going to say right bound. So it says, okay, I'm finding the maximum between this point and, now you have to drag the cursor over to the right side. Now that I'm right of that point, the maximum point, I can hit enter, and then I hit it one more time, and it tells me that point, -2.49999, that's -2.5, and the y value is 2.25. So this is C. No, this is D. So there is an absolute maximum at -2.5, 2.25. So it's going to be a little too high when I did that. And so that's the equation right there. All right, so hard to do on this, but okay, now we've got it drawn. Another option would be to do some of the characteristics by observation as you just look at this graph instead of graphing it by hand. So you won't always have to graph it. You just graph it in your calculator and you can answer some of these questions. One of them, range and domain. The domain, again, is all real numbers from negative infinity to positive infinity. Any of those x values will work. We can plug in any x we want right here. And very, very often we can. Almost always all reals here for us. The range, however, different story. What's the lowest y value we can get? Well, these arrows point down like the last problem. Negative infinity. There is no lowest. Okay, and if you were trying to do this problem and you hadn't already found that maximum point, this part would be a little difficult, or you'd have to do this. Say, how high exactly does that go? Not sure. And so you find the maximum in your calculator like this, and that is the biggest y value, 2.25. It's the biggest y value that you can have in the domain. In the range, sorry. Part B asks us about increasing and decreasing. So draw some arrows on that thing. And our first interval is going to start at negative infinity because that's the lowest number in the domain, negative infinity, or there isn't one. And what are we doing at that point, or from that point? The height, the y values are increasing. So I'll put that out here. There's an interval. The first interval is an increasing interval. And how long does it increase? To this point right here, right? Well, what is the y value at that point? Negative 2.5. So from negative infinity to negative 2.5, increasing. What happens at negative 2.5? You start decreasing. Since the y values start decreasing, negative 2.5 is the first x value where that happens, and it will decrease for infinity, or infinitely. Okay, let's do part C now. C asks about the x and y intercepts. Now, the last time we saw that the y-intercept is pretty easy to find. If your function is written in standard form, it's quite literally just the last number. It is the y value when x is 0. So if I plug in zeros for all of those things, 0 squared is 0, minus 5 times 0, which is 0, so y equals negative 4. 0, comma, negative 4. That's the y-intercept for this function. And if I hadn't done that already, or if you wanted to find it a different way, type in the equation, hit second and graph, and you find when x is 0, the y value is negative 4. That's the definition of the y-intercept. So we've got the y-intercept. X-intercept, as we know, is a little more difficult. One thing you can do to find it is to set y equal to 0, negative x squared minus 5x minus 4, and solve for x. So I'm going to divide by negative 1 first because I like these things to be positive. And this factors very easily. X plus 4, factors of 4 that add up to 5. And so my zeros, the zeros are things that I could plug in for x to make this parenthesis become 0. So look what happens if x is negative 4. Not 4, but negative 4. Negative 4 plus 4 is 0. Negative 4 plus 1 is negative 3. That's irrelevant because 0 times anything is going to be 0. One of the x-intercepts is negative 4. The other x-intercept -4, x equals -1, the opposite of this. And so we have two x-intercepts, -4, 0, and -1, 0. And we can see that on our graph. This one happened to be one that was right on the points, but I wanted to show you anyways through factoring. And then also, you can see them in your table. There's two places in our table where we see y values of zeros. Those are the x-intercepts, -4 and -1. And finally, I'll do this just one time, so you can fast forward if you already got it. If you hit second and trace, you can find zeros even if they're not nice, clean points, no matter what they are, unless they're imaginary. So if you want to find this 0, go to that 0, put the cursor on it, and then you hit the left arrow a couple times, hit enter. Hit the right arrow and get past that 0, get to the right of it, and hit enter again. Enter a third time, boom. And you can do that for both zeros. And now we only have one piece left. We have to do the in behavior. So let's start by looking at the left side. What is happening on the left side? The in behavior. Okay, so this is all the middle. The ends are out here, here, and here. The left side, it's going left and it's going down. Left is the negative x direction, and it can go that way forever. That's what the domain says. It can go that way forever. But as it goes that way, where are the y values going? Let's watch it happen. Let's go in the negative direction. Up, 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 and away. Look at my y values. Getting more and more negative. They are going to get negative forever as well. So as x approaches negative infinity, y also approaches negative infinity. What happens on the right side? Well, the right side is pointing right and also down. The right direction is the positive direction, and according to my domain, it can go that way forever. And the y direction is down, and that's the negative direction, and according to the range, it can go that way forever. So there's the end behavior. There's number 5. Let me know if you have more questions.